Okay, nice one. Sorry. Okay, so thanks guys joining me. Okay, we sort of ended last night. We did a lot of, or we started looking at sort of fractions and how to simplify fractions, things like that. So using our knowledge on indices, okay, so our newly acquired knowledge on indices to try and simplify down fractions. Okay, so we're sort of going to build on that tonight. I asked you over the course of, well, 4 days, so you might not have had the chance, but for the last 4 or 5 days, just to have if you weren't comfortable, just to have a wee check over the NAT4 stuff, okay, just take that one step back, take a breather, look at it and just familiarise yourself with that, okay. So in particular, I was speaking about, pardon me, I was speaking about adding and subtracting fractions, okay, so to get up to speed with that. We've been doing quite a bit of multiplying fractions, okay, you might not have realised, I might not have formally said it, but we've actually did quite a bit of multiplying fractions. But we'll recover it just to formally put a line under that, and we'll do a wee bit of division of fractions as well, okay, really simple method when we're dividing fractions. Okay, so that'll be really good. The adding and subtracting is probably, oddly, the hardest thing to do with fractions, all right? And it's all because we want to make the bottom the same. Okay, so let's have a wee refresher on that, what a fraction's shown us, okay? Look at it in some sort of basic terms. Okay, and then we'll build on that and look at it in regards to what we've been doing, the sort of algebraic expressions. Okay, and we'll build that into it. Okay, so again, don't be intimidated, you've actually got all the skills, okay, or we've covered pretty much everything to do with indices, okay, fractions. It's just putting these things together and building it up. Okay, again, one of these things, if you don't click tonight, don't worry about it, sleep on it, take the weekend, take a couple of days, couple of hours yourself and just going through the examples that we're doing. Okay, emailed you through the week as well. I think it was just to your college. I don't know if you put your private emails in as well, but I emailed you a link to all the YouTube videos. Okay, so for whatever reason couldn't get it in Moodle, but hopefully that's working. Okay, the link should take you sort of to a playlist. Okay, and there should be, I think, 9 videos covering the last few weeks. Okay, recommendation there, you can play it at double speed, so that's fine, go through it a lot quicker. Okay, really just picking up in those examples. You've got them written down, but I know some of you might have missed a wee step or missed a index here or a power or a division, so you might have missed something and it might not make sense. I've labelled up the videos with the dates and I've labelled up with what's in them. Okay, so it should be pretty self-explanatory. Again, if you need anything, give me a wee shout. Okay, so let's get into it tonight. Usual. Okay, so let's have a wee refresher about fractions. Okay, so what I sort of asked you to look at was sort of adding and subtracting fractions just numerically. Okay, so that's sort of NAT4, probably lower than that sort of level. Okay, just sort of introducing you and easing you into fractions. That's really easy to do. That addition, because the bottom is the same, okay, so both the denominators are a 5, we can add them together. Okay, so we will build up the complexity, so just be aware. Okay, so just getting it at this stage is perfect. So 4 out of 5. Okay, 4/5 that will come to. Okay, likewise, we sometimes see fractions. Okay, it's the same denominator, but when we add them together, okay, they're going to give us a sort of top heavy number there. Okay, so 12/8. Okay, now a couple of things with this. Okay, a couple of things to be aware of. One, we want to be able to simplify that. Okay, so understanding how we simplify that down. Okay, and that's getting it to the lowest common factor. Okay, so we've spoken a lot about factors, so it's a number that goes into both of those terms. Okay, so they're both on the 2 times table. They're also both in the 4 times table. Okay, so that's important. Okay, if we were to do 2 into that, we'd get 6 over 4. Again, we can simplify that further. So we've done a lot of that as well, taking the fractions as far as we possibly can. So we can take that further. We can actually take that to 3 over 2. Okay, and it simplifies form. Okay, so just making sure we take fractions to as simple as we can possibly make it. Okay, so you can have fractions that are top heavy, that's not a problem. Okay, and we'll go over that a wee bit, I think. Yeah, just go over that. Okay. So that was with the same denominator. Okay, so the same bottom term. Okay, but we're starting to look at things where the term is going to be, or the denominator is going to be different. Okay, so just a wee repeat on that. So we want to make the denominator the same. We can't add that together instantly. We need to have the same number in the bottom. Okay. How we do that is, well, I use the process smile kiss, or kiss smile. Okay, there's lots of different names for it and maybe lots of different steps that take you through it. Okay, it's all essentially the same thing. Okay, what you're just doing is multiplying 2 bottom terms, okay, to get a common denominator. Okay, in this case it'll be 6. You're taking the top of one fraction, multiplying it with the bottom of the other, taking the bottom of the other and multiplying it. Okay, so it's a cross and a wee smile underneath. Okay, so a kiss smile, something along those lines. Okay, so that's essentially what we're doing. So the bottom of our new fraction is going to be those bottom terms multiplied together. Okay, so 3 times 2 in this case is going to be 6. Okay, 2 times 2, okay, the red line, okay, is going to give us 4. The sign stays the same. 3 times 1 is going to give us 3. Okay. That's also the same if we wrote it out, if we did 4 over 6 plus 3 over 6. Okay, now the denominator is the same, we can sort of pull that together. Okay. That's the same way of writing it. Okay, so don't worry about that. So going through that then, that'll give us 7 over 6. Okay. Same with subtraction in that case. Okay, so same with subtraction. Okay, we do the same process. We want to multiply the bottom terms, okay, to get a denominator down the bottom. Okay, in this case it'll be 21. Okay, so 3 times 7. Want to multiply it across your sign. Okay, so the 5 times 3 gives 15. 7 times 1 gives 7. Okay. So that's just, what does that bring us to? Oh no, sorry, it was a negative. That was close. Sorry. Be very careful. That sign in the middle is a negative. Okay, so 15 minus 7 leaves us with 8. My God, where are we? 8 over 21. Okay, we can't simplify that down. Sometimes at this stage you'll be able to simplify that down and take it as easy, but there's nothing that goes into 8 and 21, so that's as simple as it can possibly be. Okay. That's the sort of process that Nat4 sort of takes you through. Okay, that sort of kiss, smile. idea. Okay, so we're multiplying across the sign, multiplying the both terms at the bottom, so we're getting a common denominator, and we can sort of add them or take them away. Okay, is everyone sort of comfortable with that? Okay. Cool. Okay, so let's get into it. Okay. Let's do that algebraically then. Throw a couple of letters in there. Okay, and you'll start to see that there's no difference. Okay, we're just starting to use our skills that we understand about indices, multiplying different letters together. All those just come into it. Okay, so don't be intimidated when you're starting to throw letters into it. So algebraic fractions. Okay. Okay, so the term in the bottom is the same. So simple case of adding two terms at the top. Okay, so the term in the bottom is the same, so we can just add the two terms at the top. Simple. Okay. Remember, we can add like terms. Okay, so again, two letters down the bottom are the same, so the denominator is the same. So we just get 5a plus 3a over b. Okay, so we're just going to get 8a over b. Okay. Let's throw a wee bit more complexity in there. Okay. We want to make the numbers at the bottom the same. Okay. Now some methods tell you that you could just multiply the top and bottom of the second one by 2 to get that number up. Okay, and that's a good method. It's a reasonable method, but it's a new method, and I'm not going to throw it in to confuse you. I'm just going to stay consistent, and we'll go through the sort of kiss smile method. Okay, so we'll just stay consistent with that. Okay, so kiss smile, multiplying the bottom terms across. Okay, so get a term in the bottom by just multiplying those together. 8 times 4 is going to give us 32. Okay. Top of the left hand side, bottom of the right hand side is going to give us 4y. Okay, it's a plus sign in the middle, and then going across again gives us 16y.
Excuse me, Daniel, could you just not use 8?
So that's what I was saying. So you could, there's a method. I wanted to stay consistent. Okay, and that's the thing. I didn't want to throw another method in and change that way. Now you're right. You're absolutely right, Sandra. If you are comfortable with fractions, you could have made this term 8 by simply multiplying both of them by the number 2. Okay, and I'll walk through the solution for that as well. Okay, but doing the kiss smile method gets you the exact same answer. Okay, it's more likely that the kiss smile method will be the better way to go in the exam. All right, so 4y plus 16y gives you 20y over 32. Okay, and we can simplify those numbers. So remember, we can simplify each part of that expression. So that 20 over 32. Okay, if you think about everything they're on the 2 times, they're on the 4 times table. Okay, so they're both in the 4 times table. So you're going to get 5y over 8. Okay. Okay. So this simplification is pushing it a wee bit. If you simplified that and said, right, they're both in the 2 times table, okay, and you got 10y over 16, you would then ask yourself the question in the exam, can I take that even further? Okay, and the answer is yes, they both can be divided by 2. Okay, so it would be 5 over 8. So you would arrive at the same answer, you would just add in a different step. Okay, so that's pretty common. Don't worry about that. If you need to simplify it over 2-3 lines maybe. Okay, just make sure you're thinking about it and going right through that process. Okay, so the question was asked, could we, pardon me, just make that second term, okay, over 8. Okay, and to do that, we could essentially take that term and just multiply the top and bottom by 2. Okay, so we don't have to do anything to the first term, that's already over 8. Okay, so if we multiplied the top and bottom over 2, that would give us y over 8 plus 4y over 8. Okay, and that's a good method. That's a really good method, and when you spot that straight off, that's a good sign. Okay, that would lead you to the same answer. The reason I want to be consistent, that once we start throwing in a wee bit more complication to it, okay, a wee bit more complexity even, okay, it does get a wee bit tougher to pick that out, okay, especially if you're under pressure, okay, so I'm not going to do that, but it is a valid method. Okay, let's have a wee look. Okay, how about if we throw okay. That seems a wee bit tougher because both letters in the bottom, there's no way to get them to sort of be the same letter, I suppose. But it's following the same process. Alright, it's following the same process. We multiply down the bottom and we just do the kiss. Okay, so your top line is going to be 4a plus 3b. We're going to be over AB. Okay, that's it. That's as far as you can take that. No problem at all.
So see, like always with fractions, are you always trying to simplify it to its simplest form?
Yep.
Like
yeah.
it won't obviously tell you to do that. You just need to always do it, kind of thing. Yeah.
It will often say take it to the simplest form or evaluate to its. Once we start doing past papers, you'll see how it's worded, and yeah, it will always give you a pointer to take you there. Okay, so
That's fine.
over the next few weeks, we'll sort of have the skills to start pulling in some past paper questions. And yeah, we'll go over just exactly what the wording will be and where that sort of wants to take you. But yeah, it will say something along those lines. Okay, either factorize fully or evaluate fully, or there's always a clue. All right.
So see in this one, do you not do 4a plus 3b though? Or do you just leave it like that?
Just leave it like that. That's as simple as that can be. So you can't take that any further. And we'll start going into them soon about when we're starting to take out common factors and when we'll start doing common factors, difference of two squares and trinomials. So all that again is going to come into this. All right, so as soon as we start picking it up a wee bit.
Yeah.
Okay.
Sorry, this might be a stupid question, but why don't you add them?
The 4A and 3B
Yeah,
can't.
but it would not just be 7AB.
No. So remember we collected like terms. So the term, this term, that A, and that term, that B, has to be like if we're going to add them together. Now we could multiply them together. Okay, so if that was 4A times 3B, then you'd be 12AB. Okay, but you can't add unlike terms, essentially.
Right, okay, that's fine.
Those letters stand for something. So bear in mind, these expressions are going to be applied to sort of bigger problems. That A will stand for some sort of variable, so apples. Okay, B will stand for bananas. Okay, so you can't collect unlike terms. Okay, we go over the next few weeks, we start looking at simultaneous equations. Okay, and that will become apparent then, or more apparent. All right, so we'll start looking at really collecting like terms and creating our own equations, and then that will come. All right, so reasonable question, but yeah, we can't collect unlike terms. Okay, and that's the same as when we're collecting things like x squared terms, x terms, and when we've not got a letter. Okay, we always have to collect like for like. Okay. Right, what else we got? Okay, let's throw this in. Can't read my own writing. Okay, so let's just put in a letter in front of it. Same process applies. Going through it. Okay, so the bottom term, exactly what we said. Okay, so 6xy. Okay, the top term is going to be 9y, and that's going to be minus 4x. Okay, again, that's as simple as it goes. Okay, so we can't take that any further. Again, because these like terms. Okay. Okay, so here's how it's worded, exactly how it's worded. So the exam will give you express as a single fraction in its simplest form. All right, so it points you in the right direction. All right. Okay. Multiply the bottom terms to get your bottom denominator. Cross, cross. Okay. So your bottom term is going to be your 8x squared. Okay. Remember, you're multiplying the number. You're also multiplying the letter as well. So x times x. Okay, so we're going to get x squared. Okay. Oh, I'm doing that in red, haven't I? Okay, the blue term will be 2x. Okay, and the green term will be 12x. Okay, so we're getting 14x over 8x squared. Okay, now I could collect those terms at the top because they were like terms, they were both x. Okay, so they're both x, and they're both to the power of 1. Okay, so I could collect those at the top and get 14x. Okay, and now it's like the simplifications that we were doing last week. Okay, so early last week we were looking at sort of cancellation method. Okay, we sort of looked at the letters, looked at the numbers at the front first. Okay, simplify that down. And then we simplify the letters by doing the rules of Indus. Okay, 14 and 8. Okay, they're both in the 2 times table. Is that the best we can do? Yeah. Okay. 8 is 4. Okay. Then we've got an x in the top and x squared in the bottom. Okay. So remember our rules. Okay. Remember that rule from last week. Okay, so we can take away that from the top. So that x from the top. Okay, so we're getting x, okay, to the -1. Okay, which becomes x in the bottom line. Okay, so essentially that x there, remember that's to the power of 1. Okay, that to the power of 1 minus that 2. Okay, so we've got x to the power of 1 over x squared, which is given as x 1 minus 2. Okay, and then our next rule that we learned, if it's a negative power, then we can put that in the bottom line. It becomes a division. Okay, so we don't write that power of 1 either. Okay, so that's how we're ending up with x in the bottom there. You could just look at that and just say, I'm cancelling that with that, as long as you're comfortable with that, but that's why we're doing that. Okay, that's how we're getting to that step. Okay, so that was just the rules we looked at last week. So that's your simplest form. 7 over 4x. Okay, we can't take that any further. Okay. 2, let's put the x's in the top, see where that takes us. Okay. Okay, same rules apply. Okay, 8 times 4, cross, and then we'll cross. Okay, so kiss, smile. Bottom's going to be 4 times 8, so the bottom's going to be 32. Top term's going to be 8x. Now we plus in there, and then your bottom, your other top term's going to be 20x. Okay, we can collect like terms. We're going to have 28x over 32. We can simplify that because 4 goes into both of them. Okay, so 7x over 8. Okay, so there's no x on the bottom to cancel anything out. Okay, so that x just stays up the top. Okay, and that simplifies down. So the number 4 goes into 28 7 times, number 4 goes into 32 8 times. Okay, let's throw in one where we have to take out a sort of common factor before we do it. Okay, so this is again sort of going back to last week and what we were looking at. Okay, so if we had 5 over 4m plus 3 over 2n, okay, follow the same process. Okay, so the bottom line is going to give us 8mn. Okay. Green term is going to be 12m. And the blue term is going to be 10n. Okay. Now, looking at that straight off the bat, it's hard to do our normal cancellation methods, okay, because there's an mn in the bottom, so we can't cancel out anything. You can see straight off the bat that 2 actually goes into everything in that, right? So 2 is a common factor of every term, but how do we get that? We can't instantly do it, we can't instantly simplify this, okay, because remember, if we've got an addition or a negative up the top or down the bottom, okay, we need to cancel, when we're using cancellation, we need to cancel out exact expressions. Okay, so we can't cancel out simply by saying, well, we know they'll divide by 2. So we need to do our CDT. Okay, so we need to simplify that top line. Okay, so we've got a top line 12m plus 10n. Okay, and we're going to carry out CDT. Okay, so common factors, the first one we're going to look at. Okay, algebraic expression. Common factor, yes. Okay, 2 goes into the first one, 2 goes into the second. So we can take 2 out as a common factor. Oh. Okay, so we've simplified that term down. Now we can put that back in. Okay, and we can use our cancellation at this point, okay, to simplify this. Okay, so now it's just a multiplication of a term. Okay, so now it's a multiplication. Now the number's outside the bracket, we can simplify that down. Okay, so that simplifies down. 2 goes into 2 once. Okay, and it goes into 8 4 times. Okay, so effectively we're writing that. Okay, bearing in mind in algebra we don't write that 1. Okay, so we just write that as 6m plus 5m. Okay, a little bit confusing, that simplification. But again, as we go into, as we look through different expressions, we'll start looking at them and simplifying them down. So that's really just introducing you the fact that we do need to simplify them by going through our CDT. Okay, sometimes the simpler it is, it looks more complicated. Okay, it doesn't really, that step seems excessive. Okay, but that's how we would simplify that top line. We'd look for a common factor, take it out. Okay, so like we've been doing the last few weeks, and then we can simplify whatever's outside the bracket with that term below. Okay. Okay, so express in its simplest form. Right, if you're looking for these in the workbook, okay, I've got some we can try. 2 seconds time. Okay, so I'll go through 3 more examples and then I'll give you some to try. Okay, if you're looking for these in the workbook, okay, they're on page 33 and I've got questions 5 and 6. Okay, so I'll get you trying some in a wee minute. Okay, 33. Okay, question 5 and 6. Okay. Question 1 to 4 is just going through the really basic ones, okay? So what I asked you to have a look at last week. Alright, so if you want to practice at them, remember the answers at the back. Okay, so 5 and 6, yeah, are good ones to use for practice for that. Okay, I'm going to do 3 more examples and then I'm going to give you some to try. Okay, and that should be good timing for a wee 5-minute break as well. Okay. Bingo. Okay, so again, question would be same. Expresses a single fraction in the simplest form. Okay. Okay, we're looking for the smile down the bottom to get that denominator the same. Looking for the multiplication across, multiplication across. Okay. So 12x squared down the bottom. Okay, remember to multiply the number and the letter. Okay. On the top line, we've got 9x. And 8x. We can collect like terms, which gives us 17x over 12x squared. Done one similar to this in regards to we can cancel out the x's. Okay, so remember, if you're unsure, just look at the index rules. Okay, but essentially we can cancel out that x, cancel away that power. Okay, so simplest that can be 17 over 12x. Okay. Let's try this one. Okay. So an x term and an x squared term, same process. Multiplying down the bottom, multiply across, multiply across. Kiss smile. Okay. Bottom's going to give us 20x cubed. Okay. So remember, a rule. Okay. So we're just adding the powers together to the power of 3, okay? So that's what we're doing now. Okay. Then we're getting 7 times 5, which is 35, x squared, and then minus 12x. Okay. Now, little bit more complicated to simplify that down. Okay, but same process. We're looking at the top, we're saying how do we simplify that down? Is there a common factor? Is there a difference of 2 squares? Well, that's trinomial. Okay, we can see straight off the bat there's a common factor. Okay, the common factor can be the letter, remember. Okay, so there's an x in both of those terms. So that expression up the top, we can take the x out of. Removing that x allows us to cancel that off, okay, and it's now made that a multiple. Okay, so we can't do our cancellation when there's a add or subtract here. Okay, so we can't do the cancellation, but we can take out a common factor and create a new expression for the top line. Now that's a multiple, so that's x times that bracket. Okay, so we can now cancel out this x with one of these x's down the bottom. Okay, that becomes 35x minus 12 over 20x squared. Okay, so we've cancelled that front x. Okay. So effectively we've just been left with a bracket. Okay, but because it's on its own, we don't need to put the actual physical bracket around. Okay, if you wrote it out with a bracket, it's not wrong. You wouldn't be marked incorrect for that. Okay. Okay, one more example. What you could see. You might just get a number like that. Okay, so how would you go about doing that? So if it said expresses a single fraction, okay, in its simplest form, what it's looking for you to do is create the same denominator on the bottom. So it's the same process. Now, if it's a whole number, so 5 in this case, okay, essentially that is a fraction, but we don't write it out as one. Essentially, that's just that. 5 divided by 1 is 5. Okay, so you can write a whole number as a fraction. Okay, then that just becomes the same process. Multiply to get the same down the bottom. Okay, so common denominator. Multiply across. Multiply across. Okay, so you're kissing and you're smiling. Okay, so your bottom just becomes 3x. Okay, you're multiplying that number 1 by 3x. Okay, then you're following the same. Okay, so you have 15x minus 2. Okay, so it's just 1 times 2. Okay, that is actually as simple as it comes. Okay, so you can't simplify that any further. So there's no common factor up the top. Okay, remember you can't use cancellation. Okay, so you can't cancel out those x's, for instance, because we're taking away something in the top line. That's all one expression. Okay, that's all one expression. Okay, so we need to keep that. Okay, so I've went through quite a lot there, so I want you to go and digest that a wee bit. Okay, and then just try a couple yourself. Okay, so okay. They're all negative. Okay, so have a wee go at them. Should take you maybe 10 minutes and then take a wee 5-minute break. Okay, so if you don't get them done in 10 minutes, just make sure you get a wee 5-minute break. Okay, so we'll come back together at 7:05. Any questions before we go, guys? No? Okay, so just have a wee bash of them and then 5-minute break. Okay, so 7:05. Okay guys, so let's quickly go through the answers for you. Okay, so using the smile method, okay, you're going to get 20m squared. Okay, you're going to get 5m cubed down the bottom. Okay, simplifying that through, again we can take a common factor up the top. Okay, we can take m out. Okay, so very similar to what we just did. Okay, now we've got a multiple outside the bracket. Okay, we can use that to cancel out a wee bit. Okay, so I'll just do that to the side. Okay, a wee bit messy, but cancelling that m out with one of the m's down below. Okay, and we'll get that. Okay, so remember, that's just determining the brackets. You don't need to write the brackets if there's nothing else there. Okay, you can just leave it like that. So 20 minus 2m over 5m squared. Okay, second, very similar in respect to taking out the common factor. Okay, so I won't go through every step for the second one, but you're going to get 45b minus 24 over 20b squared. Okay, quite a messy one. Likewise, bottom one there. Okay, can't simplify that any further. Okay, so that's as simple as it goes. Okay, so
Like, can I ask a question? Sorry.
yeah, of course.
See, for the number 2, it's 45b. Do you know how it's 9 times 5 and it's b squared? Where does the square go?
So it's been simplified down. So okay, so
Sorry to be a pain.
no problem at all. Let's go through the next step. So the multiplication would be 45b squared. You're absolutely right. But then you'd be minus 6 times 4, so that would be 24b. Then you would be 20b cubed. Okay, so you'd have to look at that top line and say, can I simplify that down any more? Okay, so you would go through, just walk through your CDT process, and the first one you come to would be a common factor. Now, what's a common factor? There's no common factor when it comes to the numbers. Okay, so we can't simplify 45 and the 24, but there is a common factor when it comes to the letter. Okay, so we can take a common factor of that letter out. Okay. And then be left with a bracket of 45b minus 24. Okay, so remember, simplifying algebraic expressions, we can take out a common factor. So if you were to break that bracket again, you multiplied out that bracket, you would have 45b squared minus 24b. Okay, remember. Okay, so now we've got a multiple in that top line. Okay, we can take away that b. Okay, we can remove that b, cancel out that b with one of the b's below that. Okay, so you've got b to the power of 1 in the top line, b to the power of 3 in the bottom line. Okay, so we can cancel that out. Be left with 45b minus 24, 20b squared. Okay, we've cancelled that b there with one of the b's below. Pardon me. Okay, does that make a wee bit more sense? So you were absolutely right. So that top line will be 45b squared minus 24b when we make that multiplication. Okay, but we need to simplify that top line by taking out a common factor. This one. Okay, so I think this type is actually more simple when we get the steps. So this next type we're going to go through. Okay, so these ones can be quite messy. Okay, in that sort of format, still quite common. Okay, we're going to look at this format. Okay, so when there's an add or subtract on the bottom of the fractions. Okay, so then we need to make a common denominator down there. Okay, so let's go through. Easiest just to do one. Okay, so again, questions will be the same. Okay, so it'll be express in a single fraction. In its simplest form. Now, remember for algebraic expressions, the simplest form is when it's been factorised. So when we were simplifying trinomials, okay, the simplest form was when we had that in 2 brackets. Okay, so just bear that in mind. Okay, so it's really easy to overcomplicate this one. Okay, so you'll see what I mean. Let's take away that one, do one down here. Okay, so expressing a single fraction, x minus 1 plus 4x minus 2. Okay, so what are we seeing first off the bat? What I'm looking at, okay, is the bottom. The denominator is the most important part. So we need to make this expression, okay, the same to allow us to add. We follow the same process, okay? There's a very, very important step that we need to take. So we follow the same process in regards to we multiply these expressions together. We need to multiply the whole expression. So we need to multiply x minus 1, we put that in its own bracket, with x minus 2, and we put that in its own bracket. Okay, and then we just follow the same, okay, by doing multiplying across and multiplying across. Okay, so we follow the exact same steps. So let's just write that out, what it would look like. Your bottom, okay, we're going to put both of these in brackets. Okay, so we put a bracket around that expression, and a bracket around that expression, and then we take those brackets and we multiply them together. So we just write them out. Okay, so remember 2 brackets beside each other just means they're multiplying together. Okay, and this is where I mean the simplest form that expression can take is it's in its factorised form. So that's as simple as that can be. Okay, so we don't have to break this bracket down the bottom. Okay, so this is what I was saying with don't overcomplicate it. That's all we need to do there. Okay, so we stick the expression in the bracket, stick the expression in the bracket, and we multiply them together. That's the common denominator we want. So let's do the top. Okay. So we're multiplying across the way. Okay, so the 3 multiplies by the x minus 2. It's a plus sign in the middle. And the 4 is multiplying with the x minus 1. Now we do have to split the brackets up the top. Okay, so to simplify this fully, we need to split the brackets up the top. So let's just walk through that. So we're splitting the green bracket. Okay, 3 times x is 3x. 3 times negative 2 is negative 6. Okay, plus 4 times x. 4 times minus 1. Okay, and we don't touch the bottom expression. That stays as is. Now it's a case of collecting like terms. Okay, so that 3x and that 4x, okay, they're like terms, so we can just collect them together. We're left with 7x. Okay, likewise, negative 6 and negative 4, okay, leaves us with negative 10. Okay, that's it. That's as simple as that expression can go. So there's nothing we can do to that top line to make it simplified, and there's nothing we can do to that bottom. The simplest form that we can have that bottom in is in its factorised form. Okay, now for whatever reason, very commonly people break that out down the bottom. You don't have to. Okay, that's in its simplest form. Okay, a couple of important things we did there was you don't always get the brackets around the terms at this stage. Okay, so putting the brackets around the term makes life simpler when you take it down here. Okay, in fact you have to have them down here, but just do it in the question. Okay, there's nothing stopping you. You're not going to lose a mark if you start annotating the question up. Okay, so as soon as you get that question, the 3 over x minus 1, put wee brackets around it. Okay, you're not going to lose a mark, okay, but it will keep you right. Okay, so just get into good habits. Let's have another wee look at a couple, and then we'll try some ourselves. Okay, remember the question will be the same, so put in its simplest form, okay, in 1 fraction. Okay, if we get that, first step I would do in the actual question, I just put a wee bracket around it so I know what I'm doing. Okay. Then we just follow the process. Okay, so we multiply them together down the bottom to get our common denominator. Now, remember in algebraic functions, that's it. Okay, now I've put the x on its own in front of the bracket, just because that's the way we'd write it, that's the way we're more familiar with. Okay, if you wrote the bottom bracket, the bottom term, the bottom expression, as that, you technically wouldn't lose any marks, but that's not the way we'd usually write it in math. Okay, we'd usually have the x in front of it. That's not wrong. Okay, effectively it's the same thing. Okay, but it's not the way we'd look at it usually. Okay, so keep it in a format you'd be consistent with. So the x bracket x minus 2, so that's just the bottom terms being multiplied together. That's now in a common form. We now do the same in the top, as we always do. 3x multiplied by 4, and then a bracket. That wouldn't be in that colour. Okay, remember the top line, we need to break the bracket. The bottom stays the same. That's as simple as it comes, that's in its factorised form. Collecting the like terms. That is now 1 fraction. The top line in its simplest form, the bottom line is in its simplest form. Okay. Let's throw in a wee complication. If we had the terms on top, same thing applies. Okay, you follow the same process. Okay, I would instantly put some brackets around that term on the top, because I know I'm going to be multiplying them up and it will just keep me right. Okay, but we follow the same process. We want to get the bottom term and then the 2 top terms. Okay, bottom term in this case is going to be 18. Okay, so nothing complicated there. Top terms, we're going to have 6x plus 2. We're breaking out that top line. Just be careful with the symbols and the signs, okay? Okay, you might get to that point. Okay, what you want to recognize here is, can I take that any further? Can I simplify that any further? Remember, we can't do cancellation because there's a plus there, so we need to do CDT. Let's look at CDT. Is there a common factor? Yep. Okay, so we can take the number 3 out of that, both terms, and we'd be left with 3x plus 7. Okay, so now we can take this 3 and this 18 and simplify that down. Okay, everyone comfortable with what I just did there? So I've taken 3 as a common factor out this expression on the top. Now that it's a multiple, I can cancel that out. Okay, so 3 goes into that once, goes into that 6 times. Okay. Oops. So effectively, I'm left with 1. Okay. Algebra, we wouldn't write that one out. Okay, so I can just write that like that. That's its simplest form. Okay. That's the simplest form. If you wrote this, it's not wrong, so you wouldn't lose a mark. Okay. That just looks neater. Okay, we wouldn't, in algebra, we wouldn't write the 1 out. Okay, and that's just something you just get used to. Okay, again, that's something that will just click. It'll just look right. Okay, at one point. So the more you do, it'll just look right. Okay, we'll do one more example and then we'll try a couple ourselves. Okay, so this is as difficult as one of these questions we'll get to. Seeing that there's a lot going on, okay, so it's quite intimidating when you first see that, but just work through your process. Okay, so put brackets around each expression, then just work out your smile kiss. Okay, and just go through it. Okay, so I'm just going to put brackets around everything that I'm going to multiply out. Okay, so all those expressions, I'm going to just keep them on their own. Okay, and then walk through same process we've been doing. Okay, so I'm just multiplying the bottom terms. Don't need to do it, don't need to break the brackets. Okay, that's as simple as that goes. Multiply out the, multiply across the way. Okay, so that green line would be x plus 1, and I'm multiplying that with the other bracket there. Plus sign, and the blue line would give you 3x minus 2. Okay, now remember the top line we need to break up, okay, and then collect like terms and simplify. So that first one we just walked through our FOIL. Okay, so we're just doing x squared plus 1x minus 1x minus 1. Okay, and we're plus 3x minus 6. Okay, is everyone comfortable with where all those numbers came from? Okay, so the green terms we're just doing FOIL. So first, outside, inside, last. In fact, I did FOIL. Okay, I did firsts. No, I did first, inside, outside, last. Okay, I did outside and inside the other way around, but don't worry too much about that. Okay. So bottom stays the same. That's as simple as it comes. Okay, and then the top, I'm just collecting like terms. Okay, that 1x minus 1x cancels out. Okay. Minus 7. Okay. This doesn't actually simplify any further, this line. Okay, so I'm not going to do the CDT. Now, in fact, I'll show you how I know that. So we'd go through the CDT process. Okay, there's no common factors. It's not the difference of two squares, but it is a trinomial. Okay, not all trinomials can simplify. Okay, we cover that a lot more when we look at graphs, when we're looking at the graphs. Okay, so when we come to that trinomial, okay, our normal process would be what multiplies together to make minus 7, and then add together to make 3. Okay, you went through everything. Well, it's just 1 and 7. Okay, you can see there's no way you can get there. Okay, so it doesn't factorise. It's probably a poor example to give you at this point because we've not covered any of them, but it's there nonetheless. Okay, so that's the simplest form that goes to. Okay, you would, if you've seen a trinomial there, you would try that CDT process, but it should become very apparent very quickly that you can't factorise it. Okay. Right, let's have a go at some of these. Okay. There's nothing to trick you like that one. Well, I don't think so. Okay, so try these. Okay, let's write out the question. So express as a single fraction in its simplest form. Okay, let's have a wee look. So 1 plus. Okay, super. Have a wee bash at them. What's that? Half past. So say 3, 6, 9, 12. So let's take 20 minutes, and that means you can just have a wee walkabout as well. Okay, so work through them, and we'll come back together at 10 to 8. Okay. Okay, nice one. How did we get on? Where's the answers? Okay, so hopefully it wasn't too bad. Believe it or not, as these questions go, this is probably as hard as it's going to come up. All right, which is a good thing. Okay. Let me walk through the first one, and then I'll give you the answers for the rest, I think. Okay, so first one, 5 over x minus 2 plus x plus 3. Okay. Okay, so first thing I would do is just put brackets around those two expressions, and that just makes it a wee bit tidier. Okay, then we're multiplying the bottom, multiplying across, multiplying across. Okay, so x minus 2, x plus 3, we don't need to do anything else to that. 5 x plus 3, oops, plus 3x minus 2. Okay, remember, need to break the top brackets. 5x plus 15 plus 3x minus 6. Just be careful with that sign. Nothing gets done down below. like terms. Plus, okay. Simple as that. Okay, we can't do anything with that. We can't simplify it down any further. That is what it is. Okay. So, I don't left myself very much room. Answer for 2 x plus 1 2x okay. 3 would be 11x. Kind of right. What am I doing? 11x plus 13 over x plus 3 x minus 1. Okay, and then that will give you 11x minus. Okay, so similar questions to that, practice questions. Question 9 on page 34. Okay. Okay, so adding and subtracting algebraic expressions, that's really the extent it goes to. Okay. Now, there is, on occasion, multiplying out algebraic fractions, but multiplying and dividing is actually a wee bit easier, okay, because it's a simple case of just, as like your standard fractions with just the numbers, okay, when it's a multiple, you just multiply the top and multiply the bottom, okay, so.
Daniel, can I just interrupt you a minute, please?
Yeah, no problem.
Can you just go back over number 3 for me, please?
Oh, number 3.
Thank you.
Yep, let's have a wee look at it. Okay, so okay, so 5x minus 1 plus 6x plus 3.
I get it now. I just missed a step out. Thank you.
Oh, that should have something underneath it. Okay.
Thank you.
Yeah, spot it. Nice one. Super. Super. Okay, so that's adding and subtraction. Let's go through multiplying really quick. Okay, as I said, we've sort of been multiplying as we've been going through the different parts of this algebraic, so there should be nothing new here, okay, but you might see it come up, it might come up in the same form of question, so it expresses a single fraction in its simplest form, okay, and they'll give you something along the lines of multiply 2 over x Okay, and it's just a case of multiplying the top line and multiplying the bottom line. Okay, so it's just 6 times x squared. Okay, now I doubt they'll give you something that easy, so let's give you a few more examples of that. Three x over 6x squared. Okay, remember, can we simplify that? Always ask yourself, can we simplify that any further? Yep, we can simplify the 3 and the 6. Okay, that'll be 1 over 2, and we can simplify the x's. Okay, so we can cancel out that one with one of those down the bottom. Okay, so we get 1 over 2x. Okay, so again, this the multiplying and dividing really goes back to what we were doing last week in simplifying out those powers. Okay, so it really just works on your understanding of your Indus rules. Okay. Can't read my own writing. Okay, so likewise, like this just works on your understanding of indices. Okay, so there's nothing 5ab times 3b squared. It's just 15ab cubed. And that just becomes 21ac. Okay, and I've just put AC there just for the simple fact it's alphabetical. If you put CA, it wouldn't be wrong. Okay, so 15 over 21 we can simplify down. Okay, 3 goes into both of them, so 5 and 7. Okay, the A's actually cancel each other out. Okay, so it's 8 to the power of 1, 8 to the power of 1, so they cancel each other out. B's stay as they are, so do the C's. Okay. A squared. Remember, if you've got something like that, okay, remember that second term. If it's just standing alone, then what they're not showing you is it's actually just over 1. Okay, and then you're just multiplying it through as you would. Okay, so that simply becomes 14 4 over 3. Okay, 3 times 1 is just 3. Okay, we can't simplify that any further. Okay. Page 34, question 7 for those ones. Okay, so I won't give you any time to do them. It won't take you long just to catch up with or get up to speed with that. Hey. I always manage to get up. Okay, so let's have a think about dividing though. Okay. Do you hear any funny noises? It's my dog. That's what I'm going with. I'll stick to it. Okay, so dividing. There's a funny way of spelling dividing, isn't it? Divide. Yeah, we'll just start that again. Doesn't look right. Okay, so the trick is here when you're dividing fractions. So when you've got AB divided by D. Okay, what we're doing is we keep that the same. We change that to a multiple, and then we flip that upside down. Okay, so it becomes flip. Oh, sorry. Keep the same. Flip the sign. Flip the last one. Okay, so we flip that last fraction and then it just becomes a multiple. Okay, so let's put some numbers and letters to that. Okay, just so we can see it. Okay, if we've got 3x squared divided by 6x, 6 over x, sorry. Okay, we just follow that process. So we keep the first term the same, we change the division to a multiply, then we flip that last term. And then we follow that the multiplication process. And then we simplify that down. Okay. This is, don't want to confuse you here, but this is one of those times where sometimes easier to use a simple example of a question you know. Okay, so you know I did that last week. So if we've got 2 divided by 2, okay, we know that will become number 1. We know that will equal 1. Okay, we also know we can write that like that, 2 over 1, 2 over 1. Okay, that's what those equations are. So if we do that and we write that out, it's just 2 over 1 multiplied by a half. Okay. So it's just 2 multiplied by a half. Okay. It's just one of those times where you could just use a wee simple example just so you can follow the process. Alright, it's sometimes the best thing to do. When you just get a wee bit lost and there's too many letters, just going back to the basics, just following something you know. Okay. Okay, so nice and simple one. Okay, let's throw a wee bit more at you. This might be a 5y squared. Okay, just follow the same process. So the first term stays the same. That becomes a multiple, that flips on its head. Okay, and then you just go through the process. Okay, then you just tidy that up. Okay, so again, that x simplifies down, take one of the powers away, that y does the same. Okay, we can't simplify the 2 and the 5, so we're just left with 2 over 5xy. Okay. Really just one other one. Okay, so that might throw you off a wee bit. Okay, remember all that x squared term is, if there's a term on its own, it's just divided by 1. Okay, so if there's a term on its own, it's just divided by 1. And then it just becomes the same, that same process. First term stays the same. Division becomes a multiple, then you flip that on its head. Okay. 4x to the power of 5 times 1 is just 4x to the power of 5. Bottom becomes 3x cubed. X squared, x cubed, doesn't matter. Okay. The powers Just take them away from each other. Okay. It's left with 4x cubed over 3. Okay. So there's nothing to throw you off when it's dividing or multiplying. Okay. That's actually the easier, bizarrely, than it is to add and subtract fractions. Okay. So let's just give that a wee try. That's 10 past 8. Okay. So we try these, and it would come up in the same way, express in a single fraction in its simplest form. Okay. So give these a try. 2x squared over 3 divided by 5x cubed over 6. Okay, 2. Okay, watch out for that wee negative sign. Same process applies, so guys, don't worry about it. Oops. There's a wee tricky one. Okay. Okay, give them a try. Let's say 10 minutes. We'll come back at 20 past. All right, come back together at 20 past. Okay, guys. Hopefully, didn't throw you too much with that bottom one. Okay, very rare you'd see something like that, but there's nothing to say it wouldn't come up. Okay, so I'll just put the answers and shout out if any explanation is required. Okay, so the first one I got 4 over 5x. Okay, so it gets to 12x squared divided by 15x cubed. Okay, so we're just sort of cancelling out and simplifying from that point. Okay, number 2, throw in a wee negative sign there. Okay, again, we've seen negative signs, so we should be okay with that. Okay, that just becomes negative 10 when we multiply it by the 5. Okay, that simplifies down, just negative y over 2x. Okay, so it's quite a lot of numbers, letters, but it's just following our rules of Indus. Okay, and let's walk through this last one just to make sure. Okay, so last one. Sorry, I've had a pen. Last one, we're just going to put it into 2 multiples, so we're just going to flip that division on its head. Okay, so that first term doesn't change. Okay, but the term we're dividing by flips on its head and becomes a multiple. Okay, and that last term doesn't change. Okay, so that's all we're doing there. Okay, then it just becomes a case of 3 multiplied by x squared multiplied by 5 all over the 5x multiplied by 6 multiplied by 4x. I think my iPad's about to get up. Okay, so we're just going through that. It's 15x squared.
So doesn't BODMAS apply to that now?
So BODMAS does, but division and multiplication just done at the same time, really. So it's divide and multiply are sort of on equal levels. Okay, so you can do them side by side like you do here. Okay, so we're just fixing that top line up and then doing the bottom line. Okay, if you walked through and tried to simplify that down, you can't really do it until you finish all the multiples. Okay, so divide and multiple sort of goes in the even queue. Okay, so 3 and the 5 multiplied together make 15 times x squared. Okay, 6, the 4 and the 5 multiplied together, so you've got 20, 120 x squared. Okay, the x's cancel out. Okay, so x2, x2, x to the power of 2, x to the power of 2. So that would cancel out. That would leave you with x to the power of 0, which becomes 1. Okay, so that was the rules, one of the rules we went through last week. End up with 15 over 120. Okay, so a couple of ways to simplify that. You can see if 15 goes into 120, okay, and how many times that does that. Okay, and don't be scared just to write that down if it's quite a complex one like that. Okay, just write it down. So 15, 30, 45, 60, 75, 90, 105, 120. Okay, so it does reach 120, so it's just a case of counting how many times it goes into that. So 1, 2, 5, 6, 7, 8. Okay, so it goes in top line once, goes in the bottom line 8 times. Okay, so don't be scared of putting that in your paper. Okay, you won't lose any marks for it. Okay, that's really as sort of complex as those go. Okay, so I'm going to leave the sort of fractions where we're looking at that. Okay, and I'm going to leave you with I'm gonna work through it now. I don't expect you to take any of this in because we've been working together now. That's been two and a half hours almost. Okay, so it's a case of you might not, or you probably won't follow this. Okay, don't worry about that. Just write down the examples, and then when you take a wee breather and relax and you've got a bit of time, watch the video and then follow the examples through. Okay, so if you don't follow this or you don't pick up on it, okay, don't worry about it. Just follow through, copy the examples, and then watch the video at a later date and try and work on it. Okay, so we've looked at a lot of rules of indices when it's coming to the dividing side of it. Okay, there's one more rule that I want to put out there. Okay, rules of indice. Okay, so we go through what I mean. Okay, so we've got the AM times AN. Okay, and that leaves us with AM plus M. Okay, so we did that a couple of weeks ago. Likewise, 2 okay. Third rule we looked at was when we've got a bracket. Okay, that should be an M. The power outside it. That means you're multiplying the powers. Okay, rule 4 was when the power was 0. Okay. So anything to the power of 0 just becomes the number 1. Rule 5 was a to the negative m, and we write that as that. Okay, so that's really the 5 powers that we require to then go into the larger sort of fractions where we have quite a lot of terms in the top or the bottom and simplify them out. There's one more rule of indice that sort of stands out, but it pulls back into the surds. Okay, so it might be a good idea just to look back at the surds, just to familiarise yourself, and then just look at this one. Okay, so this one sort of ties it together. Okay, so the 6th rule of indice is A. And if we've got a fraction and we can write that like that. Okay, so that looks quite complicated. The questions themselves look quite complicated, and it's a case of just taking a big deep breath and working through the process and going through it. Okay, first thing I want to do is just remind ourselves what is a root. Okay, so let's look at what a root number is, and then we'll just break that rule down step by step. Okay, so what that's telling us, if we have root x, okay, we can write that in that form. What isn't shown when we write surds, especially in this form, is there should be like a 2 there. Okay, so remember a square root. Okay, just that square root sign is when we're effectively taking that number and we're seeing if it squares into something. So if we've got the root of 25, that becomes the number 5. Okay, if we've got the root of 36, that becomes 6. Okay, what we don't write when we normally write surds is that should be like that. Okay, now when it's a bigger root, okay, so we say root 25, when it's a bigger root, okay, so there's a 3 there or a 4 there, okay, it becomes a little bit more complex. Now if you look in your calculator, you can actually see a button for this. Okay, so either above the root button, okay, when you turn your calculator on, you've got a root button and you can put a number in there, okay, and get your root of it. Above that, if you press shift, okay, you might get root 3. Okay, I think some calculators are different. Yeah, some calculators are different. Okay, so you're looking for the root sign, but with a wee 3. Okay, so some calculators will have that button themselves. Some calculators will have a wee root sign with a box above it and then a box within it. Okay, and some will show it as a root sign with an X above it. Okay, so a lot of different ways to show that in the calculator. Okay, but let's go through what it sort of means. So that's what square root means. Okay, we don't show the wee 2 usually, but that's what it means. Okay, next to the half. What this is telling us, okay, is what number can we multiply together twice, okay, to get that number 25. Okay, so what multiplies together? To make 25, to make the number within that root. Okay, okay, and we know that it's just going to be 5 times 5. Okay, so let's throw a 3 in front of that. Okay, what that is asking us is what multiplies together 3 times to make 8. Okay, so what times what times what equals 8. Okay, so if we just go through our numbers, 1 times 1 times 1 equals 1. 2 times 2 times 2 equals 2 times 2 is 4. 4 times 2 is 8. 8. Okay, so the answer to that would be 2. Okay, if we look back at our rule and what that's actually, what we can show that as, okay, we could write that as 8 to the power of 1/3. Okay, so that might be shown as 8 to the power of 1/3. Okay, so you can show that in two formats. Okay, just like we took that here and said if we had the normal root, okay, we could show that as x to the power of half. Okay, so let's do another. Okay. So if you've got 81 to the power of 1/4, okay, we could write that like that. Okay, so that's just taking a rule that a to the n, the root goes on the outside, and that goes on the inside. Okay, so 81 to the power of 1/4. Okay, remember we don't write it, but that's to the power of 1. Okay, so how do we work that out? So what we're trying to work out is multiplies together 4 times to make 81. Okay, so number times a number times a number times a number goes 81. Okay. Now you could go through it again. 1 times 1 times 1 times 1. 1 times 1 times 1 times 1 is just 1. 2 times 2 times 2 times 2 is going to be 16. Okay, let's try 3 times 3 times 3 times 3. Okay, 3 times 3 is 9, times 3 is 27, times 3 is 81. Okay, so what looks quite difficult can be done quite easily. Okay, so this is quite a common sort of format to come up in your non-calculator. Okay, so you might get presented with 8 to the power of 1/4 and just ask, evaluate. Okay, so don't be thrown by that. Okay, just work through that. Even if you know you need to multiply something together 4 times, just write it out. 1 times 1 times 1, 2 times 2 times 2. It doesn't take that long. Okay, so 3 times 3 is 9, 9 times 3 is 27, 27 times 3 is 81. Okay. Okay, so let's look at a question that potentially quite common to come up, and it could be in the format of, oh my god, can't write. Okay. So it will give you a power and it will give you a root. Okay. Now it's important you follow the process, and it's always easier. I'm going to say always. Okay. There's always an exception to the rule, but it's always easier to do the root part first and then do the power. Okay, so if you get something like evaluate a number to the power of 3/4 or to the power of 2/5, okay, it's always easier to do the root first and then do the power. Okay, so it's going to be in that format. So let's put some numbers to that and then just work through it. Okay, so if you get the question, evaluate, okay, 9 to the power of 3/2. Now that will be the entirety of the question. Okay, and that's a really common one to come up in your non-calculator. What they're looking for you to do, okay, is just write it in that format. Okay, so 9 goes in there, your bottom number goes out, your top number goes in there. Okay, so your root is going to be your bottom number. So some people like to remember it. Trees have roots. Roots are under the tree, so roots are at the bottom. Okay, power is at the top. People with power rise to the top. Okay, so I don't know, silly we ways to remember it. Okay, so the number at the top is the power, the number at the bottom is the root. Okay, so let's look at that and think about it. So we've got square root, okay, and we've got 9 to the power of 3. Saying do the square root part first. Okay, so ignoring the power at this stage, we're just taking the square root of 9. Okay, and we know that to be 3. Okay, so go through our square numbers. Remember, we've got 1, 4, 9, 16, 25, continues on. Okay, so square root of 9, what multiplies together twice to make the number 9? 3. Okay, then you've got left with 3 to the power of 3. So, okay, so 3 to the power of 3, just 3 times 3 times 3. Okay, 3 times 3 is 9, times 3 is 27. Okay. It's one of those ones where don't overthink it, just go through the process and it'll become apparent. Okay, so really common one, quick 2 marks, boof, see you later. Okay. Wee bit trickier. Okay. Again, evaluate 125 to the power of 4 over 3. Okay, looks really tricky, but again, just follow through that process. So we can rewrite that. The root is always your bottom number, power is always the top. Okay, so we're looking for a number that multiplies together 3 times that equals 125. Okay, now quite a high number, so but just go through the process. So 1 times 1 times 1 equals 1, 2 times 2 times 2 equals 8, 3 times 3 times 3 is 27, we just did it there. Now we're getting, okay, starting to think, so 4 times 4, 16 times 4 is going to be 64, okay, so we're not quite there. 5 times 5 times 5, okay, 5 times 5 is 25, times 5, okay, 25, 50, 75, 100, 125, so we're there. Okay, so cubed root of 125, always do the root first. Okay, we're going to get 5 to the power of 4. Okay, so remember we've not touched this power yet. Okay, now if you did that power first, you're doing 125. I think my battery's going to die before we get to the end of this. You're going to try and do 125 times 125 times 125 times 125. If you're doing that in a non-calculator in your head, I'd be very impressed. Okay, 5 to the power of 4 is a much easier sum. Okay. Oops. So just doing 5 times 5, effectively 5 times 5 times 5 times 5. Okay. So we know what the power of 3 is, just multiplying that by 5. This is eating battery. Okay. Right, I'll do this one quick, hopefully the battery lasts. Okay, 64 to the power of negative 2/3. Okay, so this is mixing up 2 of our rules. Okay, we know if we've got a negative power, that goes to the bottom. Okay, so that's just 2 of our rules. So it's a negative power. To get it to a positive power, we need to go to the bottom. Okay, then we're just following through that process. Okay, so don't be put off by that. Okay, so root is the bottom number, 64 squared. Deal with the root first. What multiplies together 3 times to make 64? Okay, what did I say? 4. 4 times 4, 16 times 4 is 64. Oops. Okay, So we've got 1 over 4 squared, 1 over 16. Okay. Want you to try these. Okay, my iPad's about to die, so I won't come back on. So we'll leave it at this. So give these a wee go. 27 to the power of 2 over 3. Okay. That's the answer. So try and get the number 9. 16 to the power of negative 3 over 2. Where's the answer there? 1 over 60. Okay, so try them, and then we'll, that's it. Alright. Call it a night. My equipment's about to give up anyway. Okay guys, so that last wee bit, I sort of wanted to do just so you had it in your locker. Okay, there's a wee bit more to go, but we'll keep it there. Okay guys, I appreciate that for tonight. Any questions, remember, just drop me an email, let me know. If not, we'll get back together on Thursday next week, which is the 25th. Okay, so we'll be back together on the 25th as normal. Okay, 6 o'clock online. Okay guys, appreciate that. Again, please get in contact. Let me know. Okay, cheers guys.